Major late August weather pattern, flip, rare dual blocking and El Niño-driven national climate split. Something changed overnight, and it changed faster than the forecast models themselves seemed ready for. Just days ago, weather guidance firmly indicated that stubborn, lingering late summer heat would persist with no clear end in sight. Then, almost entirely without warning, forecast outputs shifted completely. A brand new atmospheric pattern has emerged, and its scale is massive. This system spans an entire hemisphere, stretching from Alaska's coastline all the way across the North Pole to Greenland's ice sheet. Now it's poised to settle over the central part of the country, rewriting the typical end-of-summer weather narrative that meteorologists had relied on for weeks. For weeks on end, weather models painted the same monotonous picture: endless summer heat, stagnant air, no signs of a seasonal break. Meteorologists stuck to this consistent outlook with no major signals of an imminent shift. Local daily forecasts and long-range seasonal outlooks all aligned, reinforcing public expectations that sweltering conditions would continue well into September. But overnight, every key model run flipped abruptly. This was no minor temperature tweak, but a full structural reversal of Northern Hemisphere atmospheric behavior. The new setup is no local blip, but a hemisphere-wide reconfiguration rewriting late August and early September weather nationwide. If you've spent recent nights tossing and turning because temperatures refuse to drop, if you've checked your thermostat repeatedly wondering when the sweltering heat will finally break, pay close attention. The weather shift is far closer than most people realize, arriving even faster than nearly all forecasts predicted just a week ago. I'll break down exactly how this weather transition will unfold in your area, plus a key detail most casual weather observers will completely overlook. By the end of this breakdown, you'll understand this large-scale weather system far better than anyone who only skims surface-level headlines. Most people only check daily high and low temperatures, missing the large-scale atmospheric machinery guiding weeks-long weather trends. That's why many will be caught off guard by how rapid and extreme this change will be. This is no gradual cool-down, but an abrupt pattern flip swinging from record summer warmth to early autumn chill in days, while trapping other regions in dangerous heat. This forecast relies on rare overlapping climate signals that amplify the impact of the shift far beyond typical seasonal weather changes. We'll start with the impacts that matter most for your daily life, outdoor plans, and home energy use, then unpack the atmospheric mechanics driving this major shift, and the science behind it is just as compelling as the dramatic weather changes themselves unfolding across the country. High up in Earth's upper atmosphere sits a global wind stream known to meteorologists as the jet stream. Typically, this fast-moving wind current flows steadily and straight, pushing storm systems west to east in quick succession, preventing any single weather pattern from lingering for long. Under normal late summer conditions, this jet stream stays far north, letting warm, high-pressure systems dominate the lower U.S. and lock in persistent heat. Storms move through quickly, no pattern sticks, and temperatures hold to typical summer norms. This stable setup is why we've endured weeks of unrelenting heat with almost no cooling breaks, no refreshing rain events, and no natural atmospheric reset to break the heat cycle. Occasionally, however, a massive weather feature disrupts this smooth west-to-east flow entirely. A huge high-pressure dome locks itself in place and refuses to shift for days or even weeks at a time. Forecasters refer to this phenomenon as blocking, a name that perfectly describes its disruptive effect on global wind patterns. Much like a large boulder stuck in a rushing river, this high-pressure dome blocks the jet stream's normal path, forcing the wind flow to bend and curve sharply around its perimeter. These dramatic bends create sweeping loops and meanders in the atmospheric pattern, opening a clear, unobstructed path for frigid Arctic air to surge southward from its usual polar confines. Blocking patterns trigger extreme, long-lasting weather extremes wherever they form, eliminating the constant weather progression that keeps daily conditions varied and moderate. A disrupted jet stream forces all weather activity along distorted paths, bringing extended heat waves, unseasonable cold snaps, or stalled storm systems that dump excessive rain or linger dry conditions for weeks. Most blocking events only have one high-pressure dome, making our current dual-dome setup extremely unusual and far more impactful than standard seasonal blocking. What makes this current weather setup extremely rare is that two such blocking domes are forming simultaneously on opposite sides of the continent, a rare atmospheric alignment that only occurs once every several years and demands close daily monitoring from meteorologists. Meteorologists track specific atmospheric metrics to confirm this incoming shift, and right now, multiple key indicators are all pointing to the same definitive outcome of a nationwide weather split. Dual blocking systems of this magnitude only occur once every several years, always sparking high-impact, long-duration weather across North America. Their combined influence erases normal west-to-east weather progression, freezing the overall pattern once it fully matures later this month, and creating stagnant, extreme conditions on both sides of the temperature spectrum. The first critical measurement is the North Atlantic Oscillation, which tracks pressure differences across the northern Atlantic, centered around Greenland. When this index drops into negative territory, it signals strong high pressure building over Greenland, forming our first stationary blocking dome. The latest observational data shows this index plummeting negative around the 24th of the month, and it's projected to stay firmly negative through early September. This is not a short-term, one-off atmospheric fluctuation, but a sustained large-scale shift that consistently directs dense, cold polar air toward the eastern half of the United States. A sustained negative North Atlantic oscillation is a proven, reliable driver of late-season cold surges across the eastern and midwestern U.S., with decades of meteorological data confirming its cooling impact. Unlike fleeting one-day index dips that bring minor temporary temperature changes, this prolonged negative phase anchors the Greenland block firmly in place, keeping the distorted jet stream stable and unchanging for weeks. This guarantees our upcoming cool-down will be a multi-week climatic change, not just a fleeting preview of fall that quickly fades back to summer heat. The second key metric is the East Pacific Oscillation, which governs persistent weather conditions near Alaska and the northeastern Pacific Ocean basin. A negative reading for this index means a strong high-pressure ridge builds over Alaska and the northeastern Pacific, creating our second powerful blocking dome on the western side of North America. What stands out most to forecasters and current model data is that both of these key oscillating climate signals are turning sharply negative at nearly the exact same time, reinforcing one another instead of operating independently. These two atmospheric indices rarely sync in strong, prolonged negative phases, making the current setup exceptionally rare. Their simultaneous shift creates symmetric dual blocking on both sides of the continent, squeezing the central atmospheric flow and forcing a sharp, unyielding north-south weather divide across the entire United States. This atmospheric synergy amplifies both the northern cool-down and southern heat wave far beyond the strength of a single blocking system acting alone. Imagine dual, impenetrable, high-pressure barriers forming on the eastern and western sides of the continent, pinching and bending the jet stream on both its northern and southern flanks. Trapped firmly between these two stationary blocking systems, cold air over the nation's interior has no path to escape except directly southward. No upper atmosphere force can divert this dense cold air east or west, leaving only a direct southward path through the country's central corridor. This focused unidirectional airflow creates a razor-sharp temperature divide with no gradual transition between hot southern air masses and cold northern air masses. It's important to note a key discrepancy between major global forecast models. This is no minor technical detail, but the single biggest variable shaping the final late August and early September forecast. The two most relied upon meteorological models, the American GFS and European ECMWF forecast systems, fully agree on the big picture. Dual blocking patterns are forming, and significant cooler air is preparing to move southward into the U.S. Where they differ sharply is in the intensity of the blocking systems and the southern coverage of the cold air intrusion. Both models have long-standing strong accuracy track records for seasonal pattern shifts, with their current disagreements stemming from subtle differences in calculating block strength, stability, and persistence over time. This is legitimate atmospheric uncertainty that will fully resolve as the blocking pattern nears its peak strength in late August. The American model predicts a stronger, more robust dual blocking system, pushing cold air significantly farther south across the country, potentially reaching the Gulf Coast. The European model also confirms a definitive cooling shift, but forecasts a much milder, more contained change, with cooler temperatures limited strictly to northern regions and minimal to no cooling impact on southern and Gulf Coast states. This critical model discrepancy is the biggest source of forecast uncertainty right now, and it will ultimately determine whether the southern U.S. gets any meaningful heat relief from this pattern shift. These two vastly different outcomes will drastically impact weather conditions, safety, and daily life for tens of millions of Americans. A far-reaching southern cold push will end the ongoing southern heat wave and halt expanding drought conditions, while limited northern cooling will leave the deep south trapped in record-dangerous heat through early September. Daily model runs throughout this week will gradually narrow down the final outcome and eliminate this uncertainty. There's a third foundational factor powering this entire nationwide weather transition, a rapidly strengthening El Niño in the tropical Pacific Ocean. The Climate Prediction Center estimates a 90% chance this will develop into a strong El Niño event through fall and winter, and it's directly shaping this week's unprecedented national weather changes. El Niño reshapes global weather patterns for months at a time, and its late summer strengthening means its powerful atmospheric influence is already fully active over North America, accelerating our ongoing pattern shift and stabilizing the dual blocking setup. El Niño warms a vast, expansive stretch of the tropical Pacific Ocean, shifting the location and intensity of equatorial thunderstorm activity worldwide. This subtle but powerful oceanic shift rearranges the global jet stream pattern entirely, altering atmospheric conditions thousands of miles away from the tropical Pacific. It's a perfect real-world example of the tight, interconnected relationship between ocean surface temperatures and large-scale atmospheric weather systems across the globe. Right now, this Pacific warming trend is actively driving and sustaining our blocked jet stream pattern, a tangible, strengthening climatic trend, not random model error or short-term weather noise. Warm ocean waters act as a massive global atmospheric engine, pumping excess heat and moisture into planetary wind circulation systems. This consistent oceanic forcing forces the jet stream into its distorted blocked shape and sustains the dual high-pressure domes over Alaska and Greenland. As El Niño continues to strengthen in the coming weeks, this unique dual block pattern will grow more stable and far more resistant to breakdown or reversal. Let's break down the day-by-day timeline of this historic weather shift, as precise timing is everything for planning weekly routines, outdoor activities, agricultural operations, and storm safety preparations. You'll already notice subtle but noticeable weather changes for the rest of this week, with mild, cooler air gradually spreading across parts of the northern and central country. Crucially, this first mild cool spell is only a preview, not the main weather event that will define late August. Many casual weather observers mistakenly mistake this mild early cooling for summer's official end, a common forecasting misjudgment that leads to misplaced expectations. This preliminary cool-down is temporary by design, created by the transitioning atmosphere to lull observers before the major, pattern-altering weather transition fully arrives. Behind this brief cool snap, intense summer heat will quickly rebuild and rebound across most of the country. You may enjoy pleasant, crisp, cool mornings with comfortable low humidity, only to see temperatures climb rapidly back to sweltering summer-like levels by mid-afternoon. Northern regions that endured record extreme heat just days ago now see milder daily highs, offering a short-lived temporary reprieve from the relentless heat. This back-and-forth temperature swing is exactly like an ocean wave pulling far back before crashing powerfully ashore. The full atmospheric pattern shift is not yet complete, and the old summer regime is still fighting to retain control. This fluctuating temperature cycle is characteristic of all major atmospheric transition periods between seasons. The old stable summer heat pattern fights fiercely to persist, while the new fall atmospheric regime steadily builds strength, creating inconsistent day-to-day and morning-to-afternoon weather swings across nearly every state. These rapid fluctuations will continue until the dual blocking system fully locks in place. The true turning point arrives definitively around the 25th and 26th of the month, when the dual blocking patterns fully mature and become stationary. High pressure will anchor firmly and simultaneously over Alaska and Greenland, carving a deep, persistent north-to-south trough in the jet stream across the country's central corridor. This powerful trough will trigger a widespread, forceful cold front surging steadily southward. This is the main cooling event, no longer just a minor preview of fall. After this critical date, the atmosphere locks permanently into its new fall-like state for late August and early September. Temporary heat rebounds end entirely after this transition, and northern cooling becomes consistent and permanent through late August and early September. The Midwest, Great Lakes region, Ohio Valley, and Northeast will see temperatures drop 10 to 15 degrees below seasonal average, with the coldest interior pockets experiencing up to a 20-degree temperature anomaly. For late August, this is an extreme and unprecedented temperature shift, prompting many residents to pull out stored jackets and long sleeves weeks ahead of the typical fall schedule. The chilliest overnight lows will dip solidly into the 50s Fahrenheit, and if the American model's forecast holds true, some northern interior areas could see upper 40s, a clear, vivid early autumn preview in the middle of calendar summer. These temperature anomalies are highly unusual for late August, when nearly all of the nation is typically locked in consistent summer warmth and humidity. Crisp 40s and 50s overnight lows bring full fall-like weather weeks ahead of schedule, cutting short the usual duration of northern summer heat dramatically. While the northern and eastern U.S. enjoys refreshing, long-awaited cooling relief, the exact same atmospheric pattern creates a harsh, dangerous contrast for the southern half of the country, a hidden weather twist most casual weather watchers will miss entirely in surface-level forecasts. A sharply bent jet stream does not only create cold northern troughs that pull down polar air, it simultaneously builds intense, stationary high-pressure heat ridges on the opposing southern side of the jet stream. This amplified pattern will push a strong, unyielding heat dome over the western and south-central U.S. for weeks. Most mainstream weather headlines will only highlight the welcome northern cooling trend, leaving millions of southern residents completely unaware of the worsening extreme heat and drought unfolding in their backyards. This stark national weather split is the most underreported, impactful part of the entire late-season pattern shift. Just as northern communities break out sweatshirts and enjoy cool, crisp air, southern and desert southwest regions will face relentless, life-threatening extreme heat. This is no minor weather footnote or temporary spike. It is a weeks-long extreme weather event with serious public health and agricultural consequences. The Climate Prediction Center has issued official ongoing warnings for extreme heat and rapidly developing drought across the entire southern U.S. These alerts target high-risk conditions that threaten human health, livestock safety, crop yields, and local ecosystem stability. This is record-tier heat paired with fast-spreading drought, worsening by the day under the stagnant, unmoving heat dome dominating southern skies. Topsoils will dry out extremely rapidly, creating a self-reinforcing heat cycle that elevates routine summer warmth to a serious environmental hazard. North America's weather is effectively acting like a perfect seesaw, cooling relief and fall comfort for the north locks in oppressive, unrelenting heat for the south. Dry soil loses all cooling surface moisture, spiking daytime surface temperatures dramatically each day with no overnight recovery. Extreme heat worsens drought conditions, and worsening drought further amplifies surface heat, forming a vicious feedback cycle that only major widespread rain events or a full pattern breakdown can break. Once fully established, this cycle can persist for weeks with minimal natural relief. Desert Southwest daytime highs will continue soaring to 110 to 115 degrees Fahrenheit daily with no meaningful cooling breaks. South Central and Southeastern states will see widespread triple-digit temperatures with oppressive summer humidity pushing heat index values far higher than actual air temperatures. Worsening drought conditions drastically amplify this heat risk. Dry, parched soil cannot cool itself like moist, vegetated ground, so each scorching day bakes the earth harder, radiating more stored heat overnight and raising temperatures the following day. This dangerous feedback loop is extremely difficult to break once fully entrenched. Southeastern atmospheric humidity cripples the human body's natural evaporative cooling ability, drastically raising the risks of heat exhaustion and heat stroke for outdoor workers, children, elderly residents, and pets. This stark national weather divide, cool, comfortable northern conditions versus brutal, dangerous southern heat, is the core defining story of this rare atmospheric pattern. A single sharp atmospheric boundary splits the country's upcoming 2-week forecast entirely into two opposing climate regimes. How far south the advancing cold front ultimately pushes will determine which southern regions escape the extreme heat entirely and which remain trapped under the heat dome. This sharp divide delivers two completely opposite weather experiences nationwide over the next 2 weeks. Northern areas get an early, prolonged autumn preview, while southern regions face the most intense, dangerous heat of the entire summer season. If the American model verifies and the dual blocking pattern holds strong, the cold front could reach the Gulf Coast by early September, delivering an unprecedented late summer cool down for heat-stricken southern areas that have endured months of unrelenting warmth. If the European model proves accurate, cooling relief will stall out firmly before reaching the deep south, leaving those regions trapped under the oppressive heat dome for additional weeks. This critical outcome impacts southern temperatures, outdoor public safety, crop health, residential water conservation, and regional energy usage, standing as the forecast's most critical variable. This model difference is not a technical triviality. It defines daily weather conditions for tens of millions of people across 2 full weeks of late summer. This major nationwide pattern shift won't unfold without significant atmospheric turbulence and active storm activity across transition zones. Colliding cold polar air and stagnant warm, humid southern air triggers enhanced active storm activity with more widespread severe weather forecast as the cold front steadily advances southward. Major air mass clashes always spark convective storms, and this late summer collision fuels multiple days of thunderstorm activity along the frontal boundary. Thankfully, this evolving event is not shaping up to produce a major tornado outbreak. The primary storm hazards are damaging straight-line winds and large destructive hail, and understanding this specific risk profile is key to staying fully prepared and safe through the transition. Midweek, a slight to moderate severe storm risk covers the Central Plains, lower Missouri Valley, and upper Midwest, with numerous scattered strong to severe thunderstorms expected to develop daily. While tornado risks remain very low, powerful wind gusts and large hail can still cause severe property damage and widespread power outages, and should never be dismissed as minor storm activity. These central regions have steep atmospheric lapse rates right now, meaning air cools rapidly with height, creating ideal unstable conditions for fast-growing, powerful thunderstorms. Combined with strengthening overnight low-level jet winds, isolated storms quickly organize into large clusters producing destructive wind gusts that snap tree branches, down power lines, and cause lengthy community-wide power outages. Fast-growing convective storms amplify upper-level wind speeds, which crash down to the surface during storm collapse, causing widespread sudden wind damage across broad areas. Large hail is also a significant underrated threat, with strong storm cells producing hail large enough to dent vehicles, crack windows, and damage residential rooftops. Key high-risk storm zones include the northern Rockies and central high plains, with abundant upper atmosphere energy sparking consistent severe weather development. Upper Midwest storms start as hail-heavy supercells during peak daytime heating before shifting to wind-driven linear storm lines by evening hours. Isolated supercells produce the largest, most damaging hailstones, while linear storm clusters spread widespread wind damage across multiple states in a single evening. The Central Plains and lower Missouri Valley face clustered high-impact windstorms that can impact entire counties at once. Farther south, Mississippi, Alabama, and northern Florida have abundant, moist, unstable air ready for storm development, with weak wind shear limiting tornado severity but allowing sudden, intense downbursts to form. Dangerous downbursts strike with virtually no warning, bringing localized wind speeds that match weak tornadoes in destructive power. In the following days, severe storm risks gradually shift to the Ozark Plateau and mid-southern states, with isolated wind damage as the primary hazard. Central and southeastern Arizona also see enhanced storm activity as seasonal monsoon moisture interacts with local mountainous terrain. Monsoon moisture fuels localized heavy rain and isolated windstorms in Arizona, a separate storm system distinct from the central U.S. frontal activity. The overall tornado risk remains extremely low at just 2%, with only marginal, isolated, short-lived spin-ups possible, unlike the powerful, widespread spring tornado outbreaks common in the region. By Thursday of this week, storm risks shift toward the northern plains with large hail as the primary threat, while eastern Virginia and the Carolinas face localized wind damage driven by atmospheric waves moving eastward off the Appalachian Mountains. Storm risks continue shifting east and north weekly, following frontal progress and changing atmospheric instability, keeping severe weather active across broad regional zones. Practical preemptive preparedness is key to minimizing damage and injury through this stormy transition period. Reliable overnight emergency weather alerts are critical to warn residents of rapidly developing local storms while they sleep. Damaging straight-line winds and large hail are equally dangerous as weak tornadoes, with 70-mile-per-hour wind gusts capable of destroying outbuildings, damaging homes, and taking out town-wide power grids. Most storm-related injuries and property damage occur overnight while people are asleep and unaware of developing severe weather, making automated emergency alerts essential for timely preparation. Simple free preparations can prevent major losses, secure all outdoor furniture and loose items, park vehicles under covered shelter, and identify your home's sturdiest interior room ahead of incoming storms. These basic proactive steps drastically reduce storm damage and injury risks, far more effective than costly post-storm recovery efforts. These transitional storms are direct, visible evidence of the ongoing large-scale atmospheric transition reshaping the nation's weather. Each advancing cold front marks the sharp boundary between lingering summer heat and incoming fall cool air. By late August, the dual blocking pattern fully matures, expanding southern high-pressure heat ridges and shifting northern jet stream flow permanently eastward. Storms represent atmospheric friction between competing warm and cold air masses, calming significantly once the new fall weather pattern fully dominates the continent. Once locked in place, the new stable pattern diminishes northern and eastern severe weather potential, as storm-triggering temperature contrasts shift fully southward with the stationary front. Northern regions gain calm, sunny, pleasant post-transition weather for weeks, while southern areas face lingering isolated storm risks from persistent air mass contrasts along the stationary frontal boundary. For tropical weather updates, a weak tropical wave may eventually emerge off the African coastline, but the odds of land-threatening tropical development remain minimal for the next 2 weeks. The exact same large-scale dual-block pattern reshaping U.S. domestic weather is actively suppressing Atlantic tropical storm growth entirely. This is a rare late August reprieve for coastal communities, as this time of year typically brings sharply elevated tropical storm and hurricane risks that are completely absent in this current hostile atmospheric setup. Strengthening El Niño boosts cross-Atlantic wind shear dramatically, tearing apart developing tropical systems before they can organize or strengthen. Southward pushing cold fronts also inject dry, stable continental air into the tropical Atlantic, further inhibiting storm formation and growth. While tropical activity can never be fully ruled out in hurricane season, major hurricane development impacting the U.S. coastline is highly unlikely through early September. Elevated wind shear and pervasive dry air create an extremely hostile environment for tropical storms to mature and strengthen. For immediate daily temperature impacts, central and northern regions gradually ease to comfortable 70s and 80s, a welcome and long-awaited heat reprieve after weeks of oppressive summer warmth. South central and desert southwest regions remain completely trapped in extreme heat, with southeast daytime highs hovering near 100 degrees and desert highs consistently hitting 110 to 115 degrees. Heat index values soar far higher than raw air temperatures across the humid south, fully justifying ongoing official heat hazard warnings. the north-south national temperature gap widens dramatically each day, creating one of the most extreme late summer climate divides observed across the U.S. in recent years. Temperatures will continue to fluctuate between mild cool downs and brief heat rebounds until the dual blocking system fully stabilizes in late August. The season's most significant impactful cool surge arrives in late August, far colder and more sustained than this week's minor preview cooling. This final powerful cool shift ends northern summer heat entirely, locking in stable early fall weather conditions through early September. At peak cooling intensity, the Midwest, Great Lakes, and Northeast drop 10 to 20 degrees below seasonal average, with widespread 50s overnight and isolated 40s in cold interior valleys. All major global weather models fully agree on the core northern cooling trend, with only the southern penetration intensity and coverage differing between American and European guidance. Universal model agreement guarantees northern cooling will occur with near certainty, with only the exact scope and severity remaining to be refined. Once fully stabilized, northern and central regions see consistent, mild, pleasant weather with 50s and 60s overnight lows and comfortable 70s daytime highs. Former persistent 90-degree heat zones moderate steadily to pleasant 70s and low 80s, and rare triple-digit heat areas ease consistently to seasonal norms. Only the deep south and desert southwest retain oppressive, unrelenting heat with minimal, delayed relief. This sustained mild northern weather will drastically shift daily routines, outdoor comfort levels, and residential energy usage for most of the country through early September. Early September extended forecasts suggest the cold front may push slightly farther south than initially projected, expanding cooling relief to more southern regions in an optimistic trend worth close daily monitoring. Extended southern cooling would halt drought expansion and drastically reduce extreme heat health risks for long-suffering southern communities. To summarize clearly and concisely, a rare dual-blocking high-pressure system anchored over Alaska and Greenland, fueled and stabilized by a rapidly strengthening El Niño, dramatically bends and distorts the northern hemisphere jet stream. This unique setup delivers unseasonable late August cool air and early fall conditions to the northern and eastern U.S., while building a brutal stationary southern heat dome that drives record extreme heat and expanding drought. This one-of-a-kind alignment of independent climate signals creates a textbook amplified atmospheric pattern, splitting the entire nation into two opposing late summer climate regimes. Clashing warm and cold air masses produce wind and hail-focused severe storms during the week-long transition period, with minimal tornado risk. The key remaining forecast question is the exact southern reach of the cooling cold front, with the American model favoring widespread, far-reaching southern cooling and the European model predicting limited, northern-only relief. Resolving this critical model discrepancy will finalize the full late August and early September national weather forecast. Three major synchronized climate signals confirm this major pattern shift is completely inevitable. While exact cold air intensity and southern coverage are still being refined by daily model runs, the overall northern cooling trend is unambiguous and guaranteed to occur. This rare alignment of independent meteorological signals gives the forecast exceptional reliability, with no random atmospheric chance driving these historic weather changes. Prolonged summer heat is finally weakening nationwide, bringing early autumn conditions to most of the country after an unusually hot summer. I will continue to track all daily model runs and atmospheric updates to deliver timely, accurate forecast changes through the transition period. Monitor local storm activity closely and prioritize personal safety through this major nationwide weather transition.